Hi everyone, I am Abhinav Kishore Shangote from B Division. Today I will going to explain you a 2D transformation in computer graphics. So let's begin. Transformation. Transformation. What is transformation? Transformation means moving a object or change its position from its original. Transformation has three types: translation, scaling, and rotation. Translation means only change in position. Scaling means change in size, and rotation means changing movement along a path, for example, 360-degree. So let's begin. Transformation. Transformation are the operation applied to geometrical description of an object to change its position, orientation, or size are called geometric transformation. So translation. Translation is a process changing the position of an object in a straight line from one coordinate location to another. We can translate a two-dimension point by adding translation distance, dx and dy. Dx means translation along x-axis and dy means translation along y-axis. Suppose the original position is x5, the new position is x dash and y dash. So x dash is x plus dx and y dash means y plus dy. X means uh, old position and dx means change translation along x-axis. So in this picture, there is a p of x5, which means its old position, and p dash x dash y dash, which means new position. Tx means translation along x-axis and dy means translation along y-axis. We can represent it in a matrix form. P is equal to xy, p dash x bar, x dash y dash, t is equal to dx dy. So there is example of translation of three coordinates A, B, and C. A is 2, 5, B is 7, 10, and C is 10, 2. Then there is a given a translation along the x and y axis. Tx is equal to 3 units and ty is equal to 4 units. So adding old, uh, by adding old to translation values, the new value becomes 2 plus 3, 5, 5 plus 4, 9. Then the new coordinate of A becomes 5, 9. And then we can also do for same things for B and C. Then the rotation. Rotation means a two-dimension rotation is applied to an object by representing it along a circular path in a xy direction. So we can rotate the object in any degree. So the new coordinates are x dash is equal to r cos phi plus theta is equal to r cos phi cos theta minus r sin theta sin phi sin theta. And also for y, the original point is x is equal to r cos phi and y is equal to r sin phi. Then this example, there is a original point P of xy. Then we rotate along a theta direction, that is P dash x dash y dash. So the total angle is equal to theta plus phi, and the equation becomes x dash is equal to x cos theta minus y sin theta. Y bar is equal to x sin theta plus y cos theta. Then we can also represent it in a matrix form. X dash y dash is equal to xy cos theta sin theta minus sin theta cos theta. We can write this equation as P dash is equal to P dot R, and the R is a rotation matrix is given by R is equal to cos theta sin theta minus sin theta cos theta. Then here is example, uh, point is 43 and rotated clockwise by 45 degree. Then we substituted degree in a matrix form. Then cos 45 is equal to 1 by root 2. Sin 45 is equal to 1 upon root 2. Minus sin theta is equal to minus sin 45 is equal to minus 1 by root 2. Then also cos theta is equal to cos 45 is equal to 1 upon root 2. Then we substituted the value and solve the equation. The final output is here. To scaling. Scaling means change in position or a size. So this operation we can carry it out for polygon by multiplying the coordinates value xy of each vertices by scaling factor del x, and del y to produce the transform coordinates x dash and y dash. So x dash is x into del of x and y dash is equal to y into del of y. We can also represent it in matrix form. So row matrix is x bar and y bar is equal to x y into identity matrix del x 0 0 del y. So we conclude so that from transformation we can change its position or size, and we can rotate, and we can also translate. Translation means change in position, and we can also rotate along any direction by putting a value of theta, and scaling, which means size of objects. So thank you.